There are a variety of different operations that we can perform on two or more sets. We're going to talk about the difference and the symmetric difference. The difference is defined as all elements in one set that are not in the other set. And we write it as, if I were to do the difference of A and B, I would want to know all elements that are in set A that are not in set B. So let's say, for instance, that we had set A that contained the elements 1, 2, and 3. And let's say that we had a set B that contained the elements 3, 4, and 5. If I were to draw those two as a part of a Venn diagram, set A would contain 1, 2, and 3. And then if I were to draw set B, I need to pick up the 3 from set B, and then 4 and 5. And so we would find out that A minus B is going to take all of the elements that are in set A and remove anything that is in set B. Well, I'm going to remove the common elements, and that is 3. And so we're going to end up with 1 and 2 because I start with set A and I remove common elements. Now, do you think that A minus B or A difference B is going to be the equivalent, I'll put a question mark here, to B minus A? Would you expect those two values to be the same? Well, the idea is that if I start with B and I remove everything in A, I'm pretty sure that B has a 4 and it has a 5. I'm going to start with B and I remove the common element, and that common element is 3. So if you'll notice, these two are not equivalent. So what I'd like to do now is find out what the symmetric difference is. The symmetric difference is all elements from both sets that are not common. So this time, instead of starting with one set and removing common elements, I'm going to start with all of the elements in both sets, and then I'm going to remove the common elements. So let's go back to our two original sets, A and B. So if A contains 1, 2, and 3, and then B contains 3, 4, and 5, A symmetric difference, which is written with a plus sign and a circle around it, I'm going to start with the elements in both of them, and then I'm going to remove anything that is common between the two, which means that I'm going to have the 1 and 2. I'm going to skip the common element 3, and then I will end with 4 and 5. So where the difference between two or more sets, I start with my original set, my first set in the equation, and I remove the common elements from the second set. The symmetric difference is where I start with the elements of both of them and remove the common elements. If I start with two sets, C and D, that are disjoint, which means that they share no common elements, then C, symmetric difference D, is going to be equivalent to C union D, because there are no common elements to remove.